Hello everyone and welcome to Tomorrow Tonight. Thanks for tuning in. Tonight we're going to work through an example problem using the kinematic equations. The problem is as follows. Marlowe is a lazy cat, but when he decides to run, he can be quite fast. If Marlowe accelerates uniformly from 1 meter per second to 3 meters per second at a constant rate of 2 meters per second squared, what will be his displacement? We should always start any physics problem with a picture. It doesn't have to be beautiful, just something that allows us to see what's happening in the problem. For this picture, I'll draw a cat with an arrow above it that says v equals 1 meter per second. Then I'll draw another cat to the right of the first one with an arrow over it that says v equals 3 meters per second. This picture shows that the cat changes its velocity from 1 meter per second to 3 meters per second. So I know a cat's moving. Next, we need to make a list of all our knowns and unknowns. The first piece of information we're given from the problem is that Marlowe has an initial velocity of 1 meter per second. I know that 1 meter per second is a velocity because it has units of meters per second, which are the units for velocity and velocity only. Next, we're told that the final velocity is 3 meters per second. Again, I know that 3 meters per second is a velocity because it has units of meters per second. Next, we know that Marlowe has an acceleration of 2 meters per second squared. Once again, the units next to the number give away that this is an acceleration. Meters per second squared will always be acceleration. Finally, the problem asks us to find Marlowe's displacement. The next thing we have to do is decide which equation we're going to use. To do that, we simply find an equation that uses the information we have and the information we want. Since we have initial velocity, final velocity, and acceleration, and since we want displacement, we can see that we need to use the third kinematic equation, Vf squared equals Vi squared plus 2AD. The reason for this is we have all or want all of the variables. We have Vf, Vi, and A, and we want D. All we have to do now is simply plug in and solve. It's just a math problem. We should get 3 meters per second, all that squared, equals 1 meter per second squared, plus 2 times 2 meters per second squared times d. This leads us to 9 equals 1 plus 4 times d. Subtract 1 from both sides and we get 8 equals 4d. Then we divide both sides by 4 and get a final answer of d equals 2 meters. So Marlowe's displacement is 2 meters. I hope this made sense as you watched, and if it didn't, please come find me for help. Thanks for watching and see you tomorrow.